Hi everyone, welcome to chapter 8. This one is on t-tests, and of course you've been learning about t-tests in the lab, and in the lab you learned that there are two types of t-tests. At least we covered two types of t-tests, and those are the independent t-test and the dependent t-test. But in this chapter I'm also going to introduce you to one you haven't heard about, and that is the one sample t-test, also called the single sample t-test. All right, so please remember that this little mnemonic that I gave you, T for 2. All right, so t-tests always compare two things. So as long as you remember that, that's going to, well, it could save you on some quiz questions and test questions, etc. So just make sure you remember the T for 2 mnemonic. All right. Before we go into the different types of t-tests, I want to talk to you about the parametric and non-parametric categories that we have for these inferential tests. So when we look at the whole slew of, hypothesis tests or tests of significance, they can be grouped into one of these two categories. The parametric tests are the ones that we're going to focus on in this class. Well, in this whole course, all right? In fact, there's only two non-parametric tests that we're going to learn about, and all the rest are parametric. So the t-test, just as an example, falls into that parametric category. So what is parametric and non-parametric? Parametric tests are really powerful tests, but they have a lot of assumptions to satisfy. Now, remember what power is, right? If a test is very powerful, that means you're going to have a really, a better chance of detecting a real treatment effect. All right, so when we say that they are powerful, that's what we're referring to. Now, the fact that they're very powerful is an advantage. Obviously, we want to be able to detect those treatment effects, but there are disadvantages associated with these tests. And that, again, as it says here, there's lots of assumptions to satisfy. Now, we have workarounds, so if these assumptions are not satisfied, we can still probably run the parametric test. But if we are strictly going by the book, we should be running a non-parametric equivalent of that test. All right, so we need to know what non-parametric tests are. So non-parametric tests are not as powerful, but they have fewer and easier assumptions to satisfy. All right, so this, again, if we look at the parametric tests, if we violate assumptions, going by the book, we should run the non-parametric equivalent test. The reason why we don't do this unless we really, really have to is because we might have found a significant effect with these tests because they're so powerful. But when we run their non-parametric equivalent, we could lose that significant effect. So we try and stay away from these when we can. As I mentioned, most everything that we cover from now until the end of the semester, those tests will be parametric. So that includes all of the t-tests and all of the ANOVAs. All right, they're all parametric. There's only the chi-square tests there's only the chi-square tests that we're going to look at that are non-parametric.